Good day, everyone. Welcome to another video on mathematics. So today we'll be looking at a very important topic in mathematics, which is probability. Probability. Now, probability is a topic under statistics. All right. If you've not done statistics before, statistics basically helps us to arrange and represent data in a meaningful way, right? So that's basically what statistics is. And under statistics, we have different aspects of it. So one of the aspects of statistics is probability. Now, like you all know, I like to give a brief definition and an overview of what the topic is before we go into some calculations and some practice questions. So let's just go straight into the video. What is probability? Now, probability is a branch of statistics, also a branch of mathematics, right? It's a branch of mathematics, also a branch of statistics that studies or deals with the study of random experiments. Deals with the study of random experiments. Deals with the study of random experiments. So I will recap that. Probability is a branch of mathematics or statistics that deals with the study of random experiments. Now, you might be asking, what are random experiments or what is random experiment? Very simple. Now, random experiments, these are experiments that their outcome cannot be predicted. Their outcome cannot be predicted. Now, what do I mean by this? Now, there are some certain kind of experiments you would perform. Now, in such a way, you would know that in a particular way, you would know the outcome of this or the outcome of this experiment. Now, say for instance, if you are preparing probably a solution in a lab, or probably you're preparing, you want to prepare a base, all right, in a lab. You have all the necessary apparatus and necessary compounds and necessary elements you need for that experiment. Now you know the outcome of that experiment. You know that, okay, this is my result. This is what I'm going to get. Now, but for random experiment, it is not so. In random experiment, the outcome is not predictable. It cannot be predicted. All right. So that is what we mean by random experiment. So what does probability do? It helps us to study, or it deals with the study of this kind of experiments. Now we have various examples of them. Types of examples of random experiments: the toss of a die, the toss of a coin, and so on and so forth. We have lots of them. All right, toss of a die, toss of a coin, toss of a dice, right, and so on and so forth. So these are all random experiments. So most of the pioneers of this topic or of this field are, you have Pascal, which is who was a French mathematician, one of the pioneers of this topic, and we also have Morogov. All right, I don't want to go into history, all right, but let's quickly go straight down into probability. So in probability, we're going to look at some words. There are some terminologies we'll be using in this topic that I would like us to understand before we go into some practice questions. So we're going to look at a lot of things: event space and sample space. Let's start with that. Event space and sample space. Event space and sample space. So I'm going to give us a basic understanding of what these words are. Now, let's start with event space and then we'll go into sample space. So event space, which is E, sample space is S. Now, what is event space? In probability, we have what we call event space, and this is what it means. But before I go into event space, let me quickly start with sample space so we can get a better understanding. Now, sample space is the set of all possible outcomes. Let me recap that again. The sample space of a random experiment is the set of all possible outcomes. Now, what do I mean by that? This is what I mean by that. If you take, for instance, a random experiment like a die, if you toss a die, now, although we know that such experiments cannot be predicted, that is, the outcome cannot be predicted, but we know the sample space, meaning we know the set of all the possible outcomes, what is likely to happen. All right. For instance, when you toss a die, the sample space you would have 1, 2, 3, 4, 5, and 6. So this is what we call sample space, because on a die you have just 6 spaces numbered 1, 2, 3, 4, 5, 6. So we say now, although we don't know the results, we don't know the outcome of that experiment, because once you toss a die, you are likely to see a 1, a 2, a 3, a 4, a 5, or a 6. All right. So the outcome cannot be predicted, but we know the sample space, meaning we know what is likely to happen. So we know that 1 is likely to show, 2 is likely to show, 3 is likely to show, 4 is likely to show, 5 is likely to show, 6 is also likely to show. This is one of the differences between probability and possibility. I don't want to go into that. There's something between probability and possibility, because most times we often confuse this concept. All right, some of you we use them in a wrong context. Probability is not the same as possibility, but that's not what I'm going into now. So please, I believe we understand what sample space is. It shows us or tells us, okay, these are all the set of all possible outcomes, meaning anything outside this set is unlikely to happen. So that simply means if I were to have a 7 and 8, it is wrong or it is impossible to have this. Why? Because this is not among the sample space sets. So I believe you understand what I'm saying now. So sample space is like a set that contains all the possible outcomes or that are likely to happen in a random experiment. Alright? So anything outside this set is unlikely or not likely to happen. So now that we've gotten that, let's quickly move on into the next one, which is event space. Now, event space is a subset of the sample space. Now, what do I mean by subset? If you've done sets before, alright, the symbol for that is E, right? Is a subset of the sample space. So this is a symbol for subset. Now, when you say subset, when you say a set is a subset from another set, alright? Now, it simply means event space was actually made or gotten from where? The sample space. So in other words, without the sample space, you don't have an event space. Whenever you are dealing with a random experiment, so the first thing you have to identify is identify the sample space, identify the event space. You don't do event space first before sample space. You identify the sample space, then you get the event space. Now, how do I get the event space? Let's say, for instance, I give you a question. In the toss of a die, what is the probability that I would have an even number? Remember, what did I say? In the toss of a die, what's the probability I'm going to have what? An even number. Now, this is the difference between event space and sample space. In that question, the sample space there, meaning what is likely to happen, all the set of all possible outcomes, what is likely to happen. You can either see a 1, 2, 3, 4, 5, 6. That is the set of all possible outcomes. But now the question now says, what is the probability of me having an even number or an even number showing up? Now this is where event space comes in. So you're going to say your event space in that case will now be the even numbers in the sample space. How many even numbers do we have here? We have 2, we have 4, we have 6. So this is the difference between event space and sample space. So event space is a subset gotten out of or gotten from the sample space. So that is what we mean by that. You can see various questions like this also. You can see questions like if a die was tossed, what is the probability of having an odd number? The same thing, the event space now is going to change. Alright, so the new event space will now be odd numbers. Alright, so that'll be 1, 3, and 5. So that goes on and on and on. We can call this E1, we can call this E2. You can also have 3. Now you can have different event space. You only have one sample space. That's another thing to take note. Another thing I want you to know. You can have E1, E2, E3. You can have various event space from just one sample space. So please, in a random experiment, in one random experiment, alright, except of cases whereby you have combination of 2 random experiments, then you can have more sample space. But in a random experiment, you just have one sample space, then you can have various event space. Alright? So now that we've established this, let's see some practice questions and apply this concept. But before we go into that, let me just show us something. Alright? Now, when dealing with probability, alright, now that I've established event space and sample space, how do we calculate the probability of an event happening? Alright? How do we calculate the probability of an event happening or relative frequency? Now, this is what we do. The probability that an event is going to happen, right? That is, we call it probability of E. Probability of E simply means this event is going to happen. So let's say, for instance, I toss a die, alright, and I ask you what is the probability that an even number is going to show up. If that was a question from me to you. Now, this is how you are going to answer the question. The probability that an event will happen, in this case, the probability that an even number will show up is the total number of even numbers in the sample space over the sample space itself. But in context, we do number of elements of event space over number of elements of sample space. Number of elements of event space over number of elements of sample space. So for that question now, the answer to that question would be the number of elements of the event space. N here simply means what are the number of elements, right? Basically, we have 3. 1, 2, 3. So the number of elements there is 3. Now the number of elements of the sample space is what? 6. 1, 2, 3, 4, 5, 6. So this is 3 and 1, 3 and 2. So therefore, the probability of having an even number when you toss a die is 1 over 2. So this is how simple probability is. Alright? Once you can get this basic understanding, it is very simple. Although there are complex ones, we have Poisson distribution, we have binomial distributions. That we might get on later, because those ones require, because in binomial, I don't want to go into that, right? But we have other complex ones too. But for the basic one, so you can understand this is the basis of probability. So next thing, we're going to go straight into some examples and see how we can apply this knowledge into some questions. Alright, so we want to look at some example or a particular example under probability using the knowledge we have on event space and sample space now. So let's go. Example 1. In a single throw of 2 pair coins, find the probability that A head appear. Now B, 2 tails appear. C, one and 1 tail appear. Sorry, 1 head and 1 tail appear. Okay, now this is a practical example of what a random experiment is. Remember what I told us about random experiments? Their outcomes are not be predicted. So this is one. Now, just like I said previously, if you were following me before, when it comes to questions involving probability, the first thing you will have to identify is your sample space. Meaning, what are the set of all the possible outcomes? What is likely to happen? Alright? What are those values or things likely to happen in this set? So let's list them out, our sample space. So say let the sample space be S. Obviously it's always S, right? Now let's talk to let's talk to each other now. When you have 2 coins, now a coin has 2 surfaces. We have the head and we have the tail. We all know that. We will represent that as H and T. So one coin has a head and a tail. But now, we're not dealing with one coin here, we're dealing with 2 coins, 2 fair coins. The word fair means no compromise, right? You will just have a head and a tail, no other side here. That's what fair means. So, now that we're having 2, so I'm going to pick another one. One coin. Remember, what we want to do now is we want to list out the sample space. If I take 2 coins in my hand now, and then I toss them, alright? Now, I want to list out all the set of possible outcomes. What's the things that are likely to show or likely to happen? I can have a head on the first coin, and I can also have a head on the second coin. Very practical. If you have two coins now, place them in your hand and you throw them. When they get to the ground, it is possible that you see the first coin on its head showing its head, second coin also showing its head. That's a possibility. That's what we just mean by sample space. We are listing out all the possibilities, things that are likely to happen. So the second possibility is we can have a head on the first coin and a tail on the second coin. This is another possibility. Alright? We can also have a tail on the first coin, and we can have a head on the second coin. Now you might be wondering, HT and TH, they mean the same thing now. No, they are not the same. They are not the same. So I will not really permit me to go into. If you are dealing with statistics, you should know that order. Okay, when we are dealing, I would have loved to go into permutation and combination, right? So when in permutation and combination, order is very of the utmost importance, but in combination, order is not really important, right? So that's the same thing that goes on here. Please, HT and TH are not the same. HT means head on the first coin, tail on the second coin. TH means tail on the first coin, head on the second coin. So please take note of that. And then another possibility, we can have tail on the first coin, tail on the second coin. So these are all the set of all possible outcomes, meaning there are no other possibilities aside this. You cannot have head, tail. Okay, let me ask you something. Can we have head, tail? You can't have head, tail. This cannot be a possibility. Why did I say this cannot be a possibility? Because this is three fair coins, and we are just what? Two fair coins. So I believe you are getting this now. So what sample space does for us is it tells us, okay, this is all you can get. Anything outside this is impossible. So that is what sample space does. Now let's go straight into event space. So now that we have the sample space, the number of elements of the sample space to be 4, now let's go ahead and get the event space. So we say let E1 be the event that a head appears. Alright? Remember I told us that event space, you can have numerous event space. You can only have one sample space. So that's why I call that E1. So E1 will be that the event that two heads appear. The event that two heads appear. So let's go. E1. So this what this is trying to actually asking you is, out of all the possibilities we have in the sample space, which of them has two heads? That's basically what you are being asked. So you're going to go to your sample space now, because I remember I told you your event space is gotten from the sample space. So you're going to go back to the sample space now and look at all the possibilities. Which of them has two heads? So that is what probability simply is. Just calculating and very simple. So let's go. We have 2 heads, right? So I'm going to put down H. Now, do we have any other possibility that has 2 heads on it? No. HT, this just has only 1 head. TH also has only 1 head. TT, even it has no head at all. So the only possibility that has 2 heads on it is just what? HH. So I'm going to just pick that as my event space. So when it comes to event space, you have to really be careful when you are picking them from the sample space. Alright, so let's go. The number of elements of E1 is 1. Just 1, right? We have just 1. So, but the number of elements of the sample space is 1, 2, 3, 4. So that's like 4. So remember the formula we said, if you want to find the probability of an event happening, which is probability of E1 is the number of elements of E1 over the number of elements of the sample space. So how many elements do we have on E1? We have 1. How many elements do we have on sample space? We have 4. So therefore, the probability of having 2 heads, or the probability of 2 heads showing or appearing, is 1 over 4. It's as simple as that. So very quickly, let's take the second one. B, 2 tails appear, the same thing. So we'll say let E2 be the event that 2 tails appear. Okay, so it's the same thing, E2. How many times in the possibilities do we have 2 tails? Just once. Look at that. TT. Oh, that's right. Number of elements of E2, that's 1. The same thing. So probability of having E2 is number of elements of E2 over number of elements of S, which is still 1 over 4. Exactly. And then the third one, see, 1 head and 1 tail. Exactly. So I'm going to say let's E3 be the event that 1 head and 1 tail appear. So now you're going to look at your event, your sample space now. Out of all the possibilities, how many possibilities do we have? 1 head, 1 tail. Alright, so let's go back. Let's go there. Remember, in any event space you are trying to form, you will always get it from your sample space. So please do not forget. So let's go. Now HH, this doesn't satisfy this condition. What are we looking for? 1 head, 1 tail. So we're going to kick off that. Head and tail, yeah, we're going to pick this. Tail head, yes, 1 head, 1 tail, exactly. I'm going to pick that. Am I going to pick tail? No, because the instruction says 1 head, 1 tail, so that doesn't satisfy that. So I'm going to end it here. So the number of elements of E3 is 2. So the same thing, the same formula, probability of E3 is equal to number of elements of E3 over number of elements of S. Number of elements of E3 is 2, that's 4. So you have 2 here 1, 2 here 2, you have 1 over 2. So the probability of having 1 edge and 1 tail is 1 over 2. So this is just the basic foundation of what probability is all about. We have complex more and more subtopics to go a lot, binomial distribution, Poisson's distribution, and so many more. Alright, so thank you so much for watching and see you in the next class.